Okay. Before we started lecture number 5, which is about level of service and capacity analysis of uninterrupted flow facilities. Uninterrupted flow facilities mean without intersections. In this course, we will talk about 3 uninterrupted flow facilities: freeways, multilane highways, rural 2-lane highways. The procedures which we are going to follow are coming from highway capacity manual. Okay, so this manual gives us a standard definition of capacity. We know a crude definition, but this one is more detailed with everything else. The manual also has the standard values of capacity under ideal conditions. Okay, so if you meet the ideal conditions, you don't need any calculation. These are the values. So you have the values for freeways, multilane highways, and rural 2-lane highways. The manual also introduces the concept of level of service, LOS. The level of service goes from A to F. This is the definition of level of service given by the manual, but the basic theme is the level of service is a qualitative measure of the quality of the highway, operational quality of the highway. If the flow is this much or the conditions of the highway are this, then what is the quality of traffic flow on it? This is indicated by level of service. And then we have the description of each level of service. The best one is A, and the worst one is which one? E, F. Okay, the worst one is F. We don't have it. Maybe some of you will have it. We don't. Then to find out the level of service, I need a value. This value will tell me what is the level of service. So that value is known as service measure. Now, as I already mentioned, we are dealing with this uninterrupted flow facilities. So in most of the cases, I need density. Okay. So for level of service, in most of the cases in this course, we will need density. Every level of service has a range of flow rate. Every level of service has a range of flow rate. The maximum value of that range is called as service flow rate. Okay, so A has a range of flow rate. Okay, when you reach the maximum of that range and you cross the maximum, you go from A to B. Okay, so that maximum value is known as service flow rate for A. And again, B has a range, and the maximum of that range is service flow rate of B, and so on. If you have flow rate, you want to convert into volume, this is how you do it. Okay, there is a conversion of flow rate into volume. In this lecture, we will discuss 2 types of uninterrupted flow facilities. There are 3. We'll discuss 2 now, and rest will be discussed in the other topic. So we will discuss freeways. So freeways are multi-lane highways, like they have more than 2 lanes. They don't have any intersections. They have only ramps. Okay, they always have more than 2 lanes. They always have median. Okay, and then we have multi-lane highways. Multi-lane highways have intersections, but the intersections are more than 2 miles from each other. They may have a median, they may not have a median. Okay, and they have more than 2 lanes. Why we are discussing these 2 highways together? Because the procedure to calculate their capacity and level of service is same. So that's why we are discussing them together. Okay, 2-lane highways are different. In both cases, for freeways and multi-lane highways, I need free flow speed. FFS, free flow speed. In both cases, the highway speed is up to free flow speed up to a flow of 1000 vehicles per hour per lane. In both cases. Okay, so up to 1000 vehicles per hour per lane, the speed does not drop below free flow speed for multi-lane highways and freeways. In both cases, I need a speed flow curve. For multi-lane highways and freeways, in both cases, I need a speed flow curve. So I need to plot a curve. I will show you. In both cases, The base conditions include no heavy vehicles on the road, so all of them are passenger cars, and all drivers are regular drivers, meaning they know the area, they know the highway. Okay, they know the directions, they know the where is the ramp and everything. Got it? Okay. So in both cases, this is the these are the base conditions. Base conditions meaning ideal, standard. Okay. Then we have the description, more detailed description of level of service. I already mentioned A means free flow speed. Okay. And the main difference between each level of service, okay, the most important difference is spacing between the cars. As the level of service goes forward, the spacing is decreasing. So here you can see up to 480, then 293 and so on and so forth. Okay. So level of service A, B and C, they are almost free flow conditions. A, B and C. Okay. They are almost free flow. So the speed is almost free flow. Okay, free flow speed. From D it starts to drop. Okay, from level of service D it starts to drop. And then we have E. Now what is E? E represents what? E represents what? What is it saying? Read. E represents what? So I want you to read one word. Very good. Capacity. Thank God. E represents capacity. Okay, E represents capacity. And when you go beyond capacity, when you go over capacity, then what happens when you go over capacity? F, traffic jam. Okay, level of service F or traffic jam. This is the speed flow curve I was talking about. You need it for the analysis of multilane highways and freeways, both. You can see the first part of the curve is what? A line, right? It's a straight line. Okay, and the speed equals to what? Speed. What is written? That's why I'm asking. Everything I ask is written. What is the speed? FFS means free flow speed. Okay, so there's a line and the speed of the line is free flow speed. Okay, then you see there's a point after which the speed starts to drop, right? That point is called as a break point. Okay, so break point is the point after which the speed starts to go down. Clear? From break point it continues till capacity. Okay, clear? Now before break point it's a line, right? What is the speed of the line? Free flow speed. Okay, so first part, this is the equation for the first part. Second part, from break point to capacity, it's a curve, right? It's not a value, it's a curve. This is the equation of the curve now. Okay, clear? What am I putting in this equation? Free flow speed, capacity. C means capacity. DC is critical density. DC is critical density. Meaning what? Density when the flow is equal to capacity. Density when the flow equals to capacity. Okay. Then I need VP. VP is the flow rate. VP is the flow rate. And then I have BP. BP means blood pressure, right? BP means what? BP. BP means break point. Okay. Clear? Okay. Yeah. So the curve ends where? Capacity. There's the end, right? If I ask you to continue the curve after capacity, what will you do? And then from maximum it will go where now? To 0. Okay. After capacity you have a jam, right? Jam means no flow. So it will go to 0. This table gives you the values and equations required for the curve. Okay. The first thing you need is what? Free flow speed. Free flow speed can be measured. All of you have done it. Where? In the term project. Okay. Some of you might be thinking we did it in my dream of it, right? No, in your term projects. Okay. You did the speed sample, right? That was measurement. And the second thing they are saying is you can predict it. Predict means calculate it. So you can measure it or you can calculate it. Got it? Okay. Then if you are doing it for freeways, then the measured or calculated predicted free flow speed must be multiplied by adjustment factor. SAF stands for speed adjustment factor. SF is what? Speed adjustment factor. You need it for which highway? Freeways. Got it? For multi highways, whatever you have, that's it. Okay, no adjustment factor. There. We will talk about the adjustment factor later on. Then the next thing is, what was C? Capacity. Okay, so here the equation of capacity for freeways and for multi highways. In both cases, you see a limit, right? There's a limit for freeways and there's a limit for multi highways. Okay, what are we using in the equation? Free flow speed only. Okay, so let's say you put the free flow speed in the equation and your value is 2500. What is the limit? 2400. So what do I do now? Equation is giving me more than the limit. What should I do? Take what? The limit or the equation? What is this? Very good. But what should I take? The limit or the equation? Tell me. The limit says 2400. The equation gives me 2500. So what do I take? The limit. Yeah, now you understand. Okay? You take the value from the equation or the limit, whichever is less. Clear? Okay. And then we have a range for free flow speed as well in each case. Okay, so there's a range of free flow speed for freeways and the range of free flow speed for multi highways. Okay, if you are not in this range, that means you have a problem with the type of highway. Okay, so for example, you are saying my free flow speed is 40, and then you are calling it a freeway. What is the range of free flow speed for freeways? 45 onwards, right? But yours says 40. That means don't call it a freeway. It's not a freeway. Got it? Okay. So if your free flow speed is out of the range, especially on the downside, if you are lower than the range, especially, that means you have a problem with the type of highway. You are calling it with the wrong name. Okay? Clear? Okay. I gave you a limit for the term projects as well, right? For the speed. How much is that? 70, right? 70 what? Kilometers per hour. 70 kilometers per hour. If you convert it, it will be 45 miles per hour. Okay. This is why I gave you this. Because if it is less than 70, then these equations will not apply. And we have to use them, right? So that's why I gave you the limit. Clear? Clear now? Okay. What else do we have? Yeah. Like we had the adjustment factor of speed, we have adjustment factor of capacity as well. CS stands for capacity adjustment factor. Which type of highway? Freeways. Anything for multilane highways? No. Clear? So adjustment factors are only for freeways. Okay. Then we have the breakpoint. Breakpoint means what? Yeah, the point after which the speed will decrease. This point. Okay. So this point for freeways has an equation. So what do I need? Free flow speed adjusted, and I need CF. CF is for what? CF means capacity adjustment. Okay. And then for multilane highways, no equation. Just this. Okay. Clear? Then I have an A value for both cases where I am using the A. Okay, so it's a constant I need for the equation. Clear? Any questions? Okay. Yeah, you can see here wherever they have mentioned the units of flow for capacity or breakpoint, they are mentioning what? PC per hour per lane, right? PC means passenger cars. Okay. Using the equations and the calculations which I just showed you, they have plotted some curves as an example for us. Okay, so we can understand what is happening. So these are the curves for freeways. On every curve you can see free flow speed is mentioned, right? How many curves we have? 5. How many? 5, right? So do we have only 5 free flow speeds? Yes. In real life, will we only have these 5 values of free flow speed? It can be anything, right? We will measure it. It can be anything. So these are just examples. They may be used, they may not be used, depending upon what? Your free flow speed. Okay? And there is no rounding off here. You cannot say my free flow speed was 58, I will round it off to 60 and use the curve. No. No. You cannot do it. You cannot do it. I am telling you because you have to do it for your term projects. Okay? So don't look for a shortcut if it is not there. Okay? Whatever your free flow speed is, okay, according to that, you will make your own curve. Got it? Okay? So we will do an example where I will show you how to make the curve, but I have already showed you the equations and everything. Okay. So you can see for the first part of the curve, it's a straight line. Okay, and then it starts to drop. Okay, the point at which it starts to drop, we call it what? Breakpoint. Breakpoint. Okay, and the last point is called as what? Last point of the curve, capacity. Okay, now you see the new thing here in these curves are these dotted lines. Okay, with every dotted line you see level of service, right? The level of service A and B and C. Okay, so the area between these dotted lines is showing the level of service. So if you are between the y-axis and the first line, level of service is A. If you are between the first and the second, level of service is B. Got it? Now how do I get these values? Again, you look at each line, they have given a value here. 45, 35 and so on. Okay? And you look at the units, passenger cars per mile per lane. This is density. This is density. Okay? Now, density equals flow upon speed. Density is flow upon speed. Look at the graph. Do I have flow? I have axis of flow, right? Do I have speed? Yes. Which axis is the flow? X axis. Which axis is the speed? Y axis. So density is x upon y, right? Density is x upon y. Okay, and if I do y upon x, it becomes what? Y upon x is slope. So what is slope here? X upon y was density, right? X upon y was density. So slope is inverse of density. Got it? Got it? Okay? Every level of surface has a density. You can see the values. These values are fixed. I did not calculate them. They are given in the manual. I took them as a test, 11, 18 and whatever. These values are fixed. They are given in a table. I will show you the table. Got it? Okay. So, for example, you pick level of surface A. What's the density? 11. To convert 11 into the slope, I should do what? Inverse. So, what is the inverse of 11? 10. Inverse of 11 is how much? Zero 0.09. 0.09 is what? Slope, right? Slope is what? Tan theta. So you pick the value of density, do the inverse, it will become slope. Then use this slope to draw this line, the dotted line. Got it? Okay. So each level of surface has a density. Take the inverse, it will become slope. What's the slope? Draw the line. Clear? Clear? Any questions? So these are the curves and examples for freeways. These are for multilane highways. But you can see the same pattern here. Dotted lines, level of service, densities, straight line, drop, breakpoint, capacity, everything. Clear? Okay, so the procedure and everything is same, only the values are different. Okay. I told you every level of service has a maximum density. It has a minimum density as well. Okay, so you can see the range for minimum and maximum for each level of service. These are densities for each level of service. Clear? What is the absolute maximum here? The highest of all values. How much? 45. 45 is my critical density now. Where am I using it? Here. In this equation you see DC, right? So DC means critical density. Density when you reach capacity. And we saw at capacity the density is 45. That's why it's written on the graph as well. Okay, so this is my DC. Clear? Any questions? Okay, so here you see level of service and densities, right? I found another graph, the consultants are using it, which is between level of service and V by C ratio. V by C is volume upon capacity. V by C means volume upon capacity. Okay, where did we use it? Anybody remembers? Where did we use the volume upon capacity? It could come in the quiz. Nobody remembers. So I put that question. Okay? Everybody is happy. We will see it now. Okay. So volume upon capacity. So you see level of service, every level of service has a volume upon capacity range. Okay. So up to 0.3 level of service is A. Up to 0.45 is the B. Up to 0.45 only. I said it's a range, right? 0.45 is the maximum. Where is the minimum? 0. 0? 0 to 0.45? Up to 0.3 is A. So B will start after A, right? So it's not from 0. All values are not from 0. They are from the previous one. So you cross 0.3, up to 0.45 is B. You cross 0.45, up to 0.65 is C. Got it? That's why it's a range. Got it? Okay. I mentioned service flow rates. Okay. Every level of service has a maximum flow rate. That is known as service flow rate. Okay. So from these curves, I can find out the service flow rates as well. How? Let me go to the bigger curve. Look at this one. These dotted lines are representing the level of service, right? The limit of level of service. Okay. Now you see here, the line for level of service A. Okay. It is intersecting the curves, right? It is intersecting the curves. If I cross the line, I cross the level of service, right? If I am behind the line, level of service A. Ahead of the line, level of service B. So this line is my limit, right? So I go to the intersection point where the line is crossing the curve. Okay, this runs here. Okay, so you see this point, right? At this point, the line of level of service A is intersecting the curve. This line is for level of service A, right? So I go at this intersection point and down to the x-axis. So x-axis is flow rate, right? So the flow rate at this intersection is service flow rate of A. Okay. If I want service flow rate for B, what will I do? I'll go to the line of B. Go to the intersection point, down the x-axis. Okay. And the point at the x-axis will be service flow rate for B. Got it? For each curve, it is different. For each line, for each curve. Each line has intersection points with all the curves, right? So for every curve, there is a different flow rate. For every curve, there is a different flow rate for A and B and C. Got it? Clear? These are the values which you see in this table. These are the values at the intersection points. So how did I get 600? Let's say, how did I get 600? This is for level of service A, right? And which free flow speed? 55. So I go to the line of A until the curve of 55. And then I drop on the x-axis. This is my 600. Okay. How do I get 990 here? 990 is for level of service B, right? So I go to the line of B to the intersection point and drop on the x-axis. Clear or not? Okay. So you draw the curve and the lines, and each intersection point will give you the service flow rates. Okay. So that one was from free flow speed curves, and this one is from the multilane highway. Okay. The first one from the freeway curves, the second one from multilane highway curves. But the procedure is same. Clear? Any questions? Yeah. Now you look here, for freeways we have adjustment factors, right? Adjustment factor multiplied with what? Capacity and free flow speed. Okay. So for freeways I need two types of adjustment factors, one for capacity, one for free flow speed. They are not in the table because it's not a single factor, there are multiple factors. Okay. Now why do we apply adjustment factors? Adjustment factors are applied whenever we don't meet the standards. Okay. If you don't meet the standard or ideal conditions, the base conditions, you have to apply an adjustment factor. We have 4 standard conditions. How many? 4. They are written here. Okay. The first one, good weather. Same as weather. Okay. Most of the year we have good weather. Not good for us, but traffic good. Okay. Second standard condition, no incidents or accidents on the road. No incidents or accidents that are blocking the road. Okay. Third, no work zone, and this is mentioned in the term project guidelines as well. When you were selecting the highway, I told you there should be no maintenance construction work going on the road. So this maintenance or construction work is known as work zone. Okay. And the third one, the last one, which I already mentioned earlier, all drivers are familiar users, regular users. Okay. We also call them commuters. Okay. Regular users means they are on the highway, they know where the highway is going, where to take the turn, this intersection, and so on. Okay, they know where they are going, not the users. Okay. Now you look at the table. We have 4 conditions, right? 4 standard conditions. Whenever you don't meet any of them, there will be an adjustment factor. Okay. For 3 conditions, adjustment must be applied to speed and capacity both. There is one condition in which adjustment is only applied to capacity. Look at the table. Tell me which condition. Second is accident. So if there is any accident or incident on the road, there is no adjustment for free flow speed. Okay. The rest of the factors will affect the free flow speed, but incident or accident will not affect. Got it? And for capacity, all 4 factors can affect. Clear? I have 4 conditions, right? So I can have how many factors? 1 for each condition, right? 1 for each condition. Okay?
So you're saying that incidents don't affect the
Free flow speed.
free flow speed?
Yes. Look at the table. Second row. How many conditions affect free flow speed? Free flow speed. How many conditions affect free flow? 3. How many factors you see with free flow speed? How many? Free flow speed. Second row. How many factors you see? How many factors you see? 1. Fasting? No? Okay. Only 1, right? How many conditions affect capacity? 4. So 4 factors, right? How many do you see with capacity? You also see 1, right? She didn't see it. Capacity. How many factors are multiplied with capacity? 1. Okay. So how do we merge 3 of speed into 1? And how do we merge 4 of capacity into 1? Okay. We take their product. Okay. So there are 4 conditions which can affect capacity. They can be 4 factors. We take all 4 of them. And the final one is their product, multiplication. Okay. So 3 factors for speed. You take all 3 of them and multiply. In the end, I need the product. Okay, clear? We have 3. But those 3 will be multiplied to get the final value. Clear? Okay, the first one is for weather. Weather affects capacity and speed both, right? So I have a table for weather, for capacity, and I have a table for speed as well, for free flow speed. Okay, this table gives you adjustment factor of weather to be applied to capacity. Okay, so you can see what type of weather we have and the value of the weather. Okay, this is to make sure that it's not subjective. When you say heavy rain, it's not because you don't have any rain 364 days, so whatever is coming from the sky is heavy rain. It's not like this when you have a value. Okay, you check the value. If you are meeting, then you take that factor. Okay, so this is for capacity, and this is if you want to apply it to speed. Okay, then we have a factor for incidence. Okay, we are applying to what? Capacity. Okay, it's not applied to speed. So what do I need? I need how many lanes I have in one direction normally without incident. If there is no incident, then how many lanes I have in one direction normally. Okay, first column. Then if there is no incident, the value is how much? 1. Okay, standard value is how much? 1. If you have an incident and the incident closed the shoulder, this is the value. The incident closed the shoulder and the lane. The incident closed the shoulder and 2 lanes. Got it? Okay. You see some of the values are not written. Why? For example, look at the first row. There is no value for 2 lanes closed. Why?
Because we have only 2 lanes. And 1 and 2 lanes cannot be closed.
Even 2 lanes are closed, then these what? Relax. Go home. Sleep. Okay? 2 lanes, both of them are closed. Highway is closed. No work to be done. Right? Okay. So those values are not written here. Then we have driver population factors. Okay. Again, you see the standard value in the first row. All drivers are familiars. All drivers are commuters. They know where they are going. Okay. Then the standard value is how much? 1 for both cases, speed and capacity, both cases. If more than 50% are familiar, we have a case. Familiar, unfamiliar, equal, we have a case. More than 50% unfamiliar, we have the value. All of them are unfamiliar. We built a highway on Mars, nobody knows. Then we have clear. Now, which one is left? There were 4 conditions, right? Incident, weather, driver, and work zone. For work zone, we don't have a table. We have some calculations to be done. For work zone, we need some calculations to be done. Okay. First thing we need to calculate is CWZ. What is CWZ? Capacity of the highway under work zone. Capacity of the highway under work zone. We need 2 things here. In this equation, you need 2 things. QDR and alpha. QDR and alpha. QDR means Q discharge rate. Okay. Q discharge rate. For Q discharge rate, I have an equation. I'll come to it. Okay. Then I have alpha. Alpha is the reduction in capacity because of work zone. Alpha means reduction in capacity because of work zone. It has a value. You can see the value. Clear? Now, let us go to the equation of QDR. It's a long equation. We have 5 factors here. The first factor is FLCSI. First factor, FLCSI, lane closure severity index. FLCSI, lane closure severity index. We have an equation for this and a table for this. Okay, what do we like? Equation or table? Table. I knew it, so there is no equation. But in the other books there is equation. Okay? But if we have the tables, fine. So for FLCSI, I should know what? How many lanes are normally open in one direction? Okay? And how many lanes are open with the work zone? How many lanes open normal? How many lanes open with the work zone? Okay? Third column is a ratio. This upon this. Third column, open ratio, OR, is a ratio of this upon this. Work zone open upon normal open. Okay? So you see the first value is how much? 1, right? What is 1? 3 upon 3. You see the third value, 0.75. What is 0.75? 3 upon 4. Got it? So if you know the number of lanes, you can calculate this yourself. No problem. I need this one. Okay? So you come to the table, fix how many lanes you have normal, how many lanes are open with the work zone, and you know SESI. Clear? You take the SESI value from here. Now, look at the first value. 3 lanes normal. 3 lanes with the work zone. What's the problem? What's the problem? Why should I apply the adjustment factor? Why I am doing this? There were 3 normal lanes. With the work zone, it's still 3 lanes. So what's my problem?
Because work system causes a slowdown.
Yeah. Yes. Okay. So even if it is close to the road, so you are just making a sidewalk, everything is open. But since it is close, we are doing some construction close to the road, it will still affect the flow. Okay. So you are right. But sometimes it's on the shoulder, sometimes it's on the median. In any case, even if the work zone is not exactly on the road, if it is close to the road, okay. And sometimes you make adjustments, right? The work zone will close 1 lane. So I'll make the median as 1 lane. So you see 3 lanes normal and 3 lanes with the work zone. But if you go in the field, they are not the same 3 lanes. The road is still affected. So in any case, the point is, any work zone on the road, beside the road, in the middle of the road, it will affect the flow. So we need an adjustment factor. Okay. So SESI from the table. FBR factor for a barrier. Okay, so as per standards, they need a barrier between the work zone and the road. That's part of the standards. Okay, standard procedure. You need a barrier between the road and the work zone. This barrier can be made up of concrete or something else. For concrete, the factor is 0. If you are using a concrete barrier, the factor is 0. For anything else, it is 1. If you are using steel barrier, wood barrier, plastic barrier, human barrier, whatever. You see sometimes people, right? The workers are there, they have seen that, right? Okay, hopefully I have not made one. Okay. Then we have factor for area type. If area is urban, factor is 0. If area is rural, factor is 1. Factor for lateral clearance, lateral distance. It's the distance between the barrier and the road. So sometimes you have a barrier and there is some distance and then you have the road. So this distance is known as F lateral. Got it? So distance will be here. F day and night, day and night. If you are doing the analysis for daytime, the factor is 0. If you are doing the analysis for night time, the factor is 1. Got it? Clear? Okay. Now remember, I am trying to calculate the adjustment factor of capacity for work zone. Okay. What is the first thing? This is what? CWZ is what? Capacity of work zone or with the work zone. Do you see a capacity equation here? In this table? Is there a capacity equation? There is a capacity equation, right? There is an equation to calculate capacity, right? Okay. This is normal capacity. And that one is capacity with the work zone. So you have 2 values, right? Their ratio is the adjustment factor. Adjustment factor is what? The ratio of work zone capacity upon normal capacity. Okay. So you have a value from here and then you have a value from the equation on the table. You take the ratio, it becomes adjustment factor of capacity for the work zone. Clear? Okay? Clear or not?
Aren't we supposed to find capacity?
You will find 2 values of capacity, one with the work zone, one with the normal, and you will take the ratio, you will have the adjustment factor of capacity. We are trying to find out the adjustment factor of capacity.
Yes, but don't we need the work zone capacity to multiply by other capacity?
Yes.
this.
Yes.
So how are we going to have this?
The other capacity, I'm using C here, not C adjusted. So for C, I have an equation. Clear or not? Any other question? Okay. Work zone also affects free flow speed. Work zone also affects free flow speed. We can measure the free flow speed. We can calculate the free flow speed. So we have a normal free flow speed, right? We have a normal free flow speed. And then we have a free flow speed with the work zone. So we have a normal free flow speed. We have free flow speed with the work zone. Adjustment factor is what? There. The ratio. The same thing which we did with the capacity. Okay, so adjustment factor is free flow speed with the work zone upon normal free flow speed. Okay, now how do I get free flow speed with the work zone? We have an equation for this. Okay, second line. Okay.
So this is only adjustment factor of free flow speed for the work zone.
Yes.
We still have three others or two
Which I
others.
already showed you.
Yeah.
Okay, so now what do I have in this equation? First of all, let us tell me which factors we already know here in this equation. Look at this equation. Tell me which factors we already know. We already discussed. Which ones?
Yeah,
LCSI has a table. Okay, this we know. What else? Which other factor we already have? Or we already know? FBR. Factor for what?
Yeah.
Barrier. Okay, concrete or else?
FDN.
FDN. Factor for what? Dead. Okay, again 0. Then we have three other factors: FSR, SAWZ, and TRD. FSR is a ratio. FSR is a ratio. Ratio of normal speed limit upon speed limit of the work zone. Normal speed limit of the work zone. Okay? This is FSR. What is SLWZ? I just told you. Speed limit with the work zone. Clear? Okay. Last one, TRD. TRD stands for total ramp density. TRD means total ramp density. We will use it later on as well, so pay attention how do we find it out. The segment which has the work zone, the segment in which you are doing the analysis, go 3 miles forward from this segment and then go 3 miles back. Total how much? Total 6. 3 miles forward, 3 miles back. Total 6. What are we doing in this? We will count how many ramps we have. So you go 3 miles forward on the map, count the number of ramps. Go 3 miles backward on the ramp and count the number of ramps on the map. Okay, don't try it on the road. You'll get killed. Okay, so on the map you go 3 miles forward, count the ramps. 3 miles backward, count the ramps. So you will have a number of ramps, right? Number of ramps in how much distance? 6. So number of ramps upon 6 will be TRD. Okay, total ramp density is number of ramps you have in this 6 miles upon the distance. Clear? Any questions?
What's FSR again? The ratio between the speed and the
Speed limit,
and the speed limit.
normal, speed limit upon those. Okay? Clear? Any other question? Okay, so we discussed the adjustment factors, all of them. Others have a table, or they have their tables. Work zone has some calculations. So next time we will do some examples with the work zone calculations. Okay? Hopefully you will remember it till tomorrow. Sure. Okay? By the way, the quiz is on Sunday, okay? Sunday.